Hi everybody, today we're going to be looking at lesson 2 on discrete data. So at the beginning of the lesson here, I just have a reminder of some of the vocabulary. Some of this we touched on briefly in lesson 1, but I'll go through these terms just to make sure everybody is familiar again. We have random variables, right? These are variables whose values are determined by chance. So for example, rolling a die. We talked about last lesson qualitative, categorical variables, all right? So those two terms are interchangeable. Sometimes people say categorical, sometimes people call them qualitative. For our purposes, we're going to stick to the word categorical, and it means that you're looking at variables that describe a particular characteristic which can be divided into categories. So non-numeric variables. And an example would be the colors of a particular model car. Now, it's important to note right here, some variables such as social security number and zip codes are considered categorical even though they're made up of numerical values. If you think of it this way, does it make sense if you add two zip codes together? Does that have meaning? Right? It doesn't. A zip code is made up of numbers, but it's a label. Same with the social security number. Like if you added them together or multiplied them, it wouldn't have any relevance or any meaning. Again, it's made up of numbers, but it's just a label, it doesn't mean anything in terms of numerical value. All right, so then we have quantitative variables. Now this is when we're talking about numeric variables. And the way you can really tell is if it's something that can be counted or measured, we know it's quantitative. Now, there's two different kinds of quantitative variables. There's discrete and continuous. So discrete quantitative variables assume values that can be counted. So for example, the number of days that it snowed in January can include a 0. A continuous quantitative variable can take any numerical value within a certain range. It's usually the result of measuring and can assume an infinite number of values. So for example, the weight of your dog. My dog might weigh 90.123 pounds and your dog weighs 10.156, right? So there's an infinite number of possibilities in terms of the weight of your dog. All right, so what I would say here is pause the video, try these, see what you can make of them, and then when you're ready, restart. Consider your classmates as observational units. Indicate whether each of the below are quantitative. Tell me if they're continuous or discrete, if they are quantitative, categorical, or not even a variable. Okay, so what I'm going to do here is I'm going to call quantitative Q, I'm going to call categorical C, and I'm going to call not a variable N. That'll save us a little time as we note each of these. So hair color is something that varies, but it's not numerical, so it is a variable and it is categorical. The number of brothers each classmate has, all right, that's a numeric value that has meaning. That's quantitative. And in this case, since it's a counting quantitative variable, this is discrete. The number of students with red hair. So there's only one answer to that question. If I say to the class, how many students have red hair? The answer may be 1, but it's not going to vary. There's like one answer for that group of people, right? So this one is not a variable. The average number of various cities, right? So again, that's something that we are counting, right? That is numeric, so that's quantitative, and it's discrete. The height of the tallest student in your class. So if I say to you, what is the height of the tallest student in our class? You're going to give me one answer. There's only one answer to that. So that would be not a variable. Whether or not a student has red hair. All right, so The categories would be you have red hair or you don't have red hair. So again, this guy is categorical. Height. All right, so if we're looking at the height of everybody in the class, for example, right, this is a measure. And because there could be infinite possibilities here, we could have, we're not talking about whole counting numbers. This is going to be quantitative and continuous. The teacher's age. If I ask the class, what is the teacher's age? There's only one answer. Since there's only one answer, this is not a variable. If I ask the class, what is your gender, right? We're going to get more than one answer. It's a non-numeric answer, so this would be categorical. The length of your signature, all right? So that's something that would be measured. That's something that would vary. So this would be quantitative. Because there's infinite possibilities, continuous. The number of states you've visited, all right? That's a counting number, right? It is numeric, but because we're counting it, that would be discrete. The zip code of your hometown. Well, hopefully you were listening at the start of the lesson, because a zip code, even though it is numeric, is made up of, and it's made up of all numbers, right? The zip code is just a label. So a zip code is categorical, right? Now, if you didn't understand why I picked that, go back and listen to the start of the lesson. All right, moving on. We're going to talk about how to organize data, because if you have a bunch of data just thrown at you and it's just sitting there and it's not organized, it's going to be very difficult to make any kind of, to understand it and to make assumptions about the data. So one of the most important things we do in statistics is organize data. All right. Now, one of the simplest ways to organize data is using a tally and a frequency table, and I'll show you how to do that. A tally is used to count the number of 1, 2, 3s, and so on. As we read the data, we place a vertical stroke in the tally column, and we use, this symbol right here once we get up to 5 occurrences. So just tallies. I'm sure you know how to do that, but I will show you. The frequency summarizes the number of occurrences of each particular data value. So once we're done tallying, we add them up. The relative frequency of a data value is the frequency divided by the total number of recorded values. It indicates the proportion of results which take that value. All right, so we're going to organize this. We're going to make it very easy on ourselves. We're going to use our tally system. All right, and we're just going to go through each value, and just as I put it in the tally table, I'm going to cross it off. So I have a 1, a 3, a 1. Now at this point, you may want to pause the video and see if you can finish tallying yourself. Okay, phew, that's all done. That took some concentration. You don't want to have any distractions when you're going through that process, because it's really easy to make a mistake. All right, so we've got it all set up. We're going to now count the tallies for each value, and we're going to record the frequency. So for number 1, we have 5 plus 3, so our frequency is 8. For number 2, we have 5 plus 4, so our frequency is 9. For number 3, we have 5 plus 1, our frequency is 6. For number 4, we have just 5. And for the value of 5, we have 2. And then we want to add those up. So 8 plus 9 plus 6 plus 5 plus 2, that gives us 30. Right, now the next part, we're going to find the relative frequency. So we're going to take the frequency divided by the total number of values. So I'll just write the fractions here really quickly. And you would just go to your calculator and put those values in. So for example, the first one is 8 divided by 30. And we get I'm going to round to the nearest thousandth, so 0.267. Right, so that's a frequency table. We have noted our frequency and we've noted our relative frequency. Right, now displaying discrete data. We use what's called a bar chart. It's also referred to as a column graph. Those are interchangeable terms. Discrete data is displayed using a bar chart, aka column graph. Possible data values are placed on the horizontal axis. The frequency of the values is on the vertical axis. Column widths are always equal, and the gaps between columns, there are gaps between columns to indicate the data is discrete. Now, this is a really important statement right here because when we look at continuous bar graphs, the columns are going to touch. So when we have discrete data, counting data, the columns are not going to touch. There'll be gaps between each column. The mode of a data set is the most frequently occurring value. I'm sure you've heard of the mode before. On a bar chart, the mode will always be the highest column. All right, let's just circle that because that's important. On a bar chart, the mode will always be the highest column. All right, so I just took the liberty of taking the chart we created on the last page and I pasted it here so it's easy to reference because we're going to use that frequency table now to create a bar chart, our column graph. And I've already labeled all of the values on the bottom. Our values were, as you can see here, 1 through 5. And then our vertical axis is the frequency. So for value of 1, we have 8 frequencies. So we're going to go up to 8. For 2, we have 9. So we're going to go up to 9. For 3, we have 6. Try to be as neat as you can. On my answer key, I used a ruler. Number 4, we have 5. And for number 5, we have 2. Value of 5, we have 2. Okay, and notice that in this case, our mode is 2, right? Because this is where we have our highest bar in our bar chart. So the mode is 2. All right, now sometimes I like to shade them. I don't know, it gives it a little depth. Makes each of the bars stand out a little bit more. You don't have to do that, but I think it looks a little bit better and it's easier to read when you do that. All right, describing the distribution of a data set. Now, we did do this in Algebra 2. This should look familiar. There's slightly different terminology for IB, so I just want to point that out. A bar graph allows us to quickly observe the distribution or shape of the data set. We can describe the distribution as symmetric, right? So in this case, we're symmetric about the mean. Negatively skewed, we referred to that in Algebra 2 as skewed left. You can say skewed left or you can say negatively skewed. What it means is so the data is skewed on the left, so the graph is a little off on the left. In terms of skewed right or positively skewed, the data is skewed on the right. Now, if we go back to the chart that we just made, if I'm trying to describe the distribution, I like to do a line over it. It just kind of helps me see better what I have. And if you notice, our data is skewed on the right. So this graph happens to be positively skewed, also known as skewed right. Now I'm going to write them both in all my answer keys because I think these are interchangeable. Right, so positively skewed, which means skewed right. All right, we're going to talk about outliers here. Outliers are data values that are either much larger or much smaller than the general body of data. Outliers appear separated from the body of data on a bar graph. Right, this is the most important thing when you're looking at a bar graph. All right, if there's any break between a bar and the rest of the bars, that is how you're going to determine whether or not you have an outlier, right? So you can see in the example here, this guy right here is broken out from the other bars. It's not near them, all right? That would indicate that that bar is an outlier. All right, so we have some practice here. 30 children attended a library holiday program. Their year levels at school are given. We want to do a frequency table. We're going to include relative frequency, and then we're going to answer some questions about this data. All right, so we're going to record all the possible values. So if you look at our data, the lowest number in our data is 6, and the highest number in the data is 11. All right, so we're going to record our values. So we've got 6, 7, 8, 9, 10, and 11. And then we're going to do the tally. So I would say pause the video, restart when you're ready, and take a look at and see if we match. All right, so we have our tallies now. We're just going to count up the tallies and record our frequency for each one. We have 6, we have 9, we have 8, we have 4, we have 2, and we have 1. If we add up our frequency column, we get 30. All right, it's not always going to be 30. That's a coincidence. We had that total on the last problem. I'm going to calculate all the frequencies by taking each we're going to calculate the relative frequencies by taking the frequency divided by the total for each one. Now you don't have to write what I'm writing here. You don't have to write the fractions. I'm just making sure I'm being very clear. And we're going to get 0.2, 0.3, 0.267, 0.133, 0.067, and 0.033. Okay, we're all ready to go. We've done step A. Now we're going to construct a column graph to display the data. So the horizontal axis is going to be all your data values. So starting at 0 and we're going up to 11. And our frequency, the lowest frequency is 1 and the highest is 9. So I'm going to do it in 2s. Seems to make the most sense to me. And then we're going to go ahead and fill in our bar chart. Now, so for the first value, 6, the frequency is 6. So you just want to center that bar right over the value. Try to make them about the same width and about the same space between each bar. Okay, for 7, we have 9. For 8, we have 8. At 9, we have 4. At 10, we have 2. And at 11, we have 1. And like I said, I just like to give it a little fill-in. It kind of helps the bar graph stand out a little bit, sheet it. just real quick. All right, and I'm also going to draw just a line over it because I want to get an idea for the general shape in case I'm asked. There we go. Great. All right, so letter B, we constructed our column graph. Now, letter C says, what is the modal year level of the children? So what is the highest bar in our graph? So that's the highest bar in our graph. That's a 9. So let's make a note. The modal year. That's just another way of saying what's the mode. The modal year is 7. Okay, that's the value that occurs most often. All right, letter D says describe the shape of the distribution. Are there any outliers? Okay. Well, we already have our highlighted green helping us look at the shape. This data is skewed on the right of the graph. So this is a positively skewed graph. Which I'm going to note means skewed right. And because all the bars are right next to each other, we have no outliers. Okay. We're good. Letter E, what percentage of children were in year 8 or below? This is a great question, and now we finally get to use our relative frequency. So let's highlight the percentage of children that were in year 8 or below. So that's going to include 6, 7, and 8, right? Those values right here. So for letter E, we're going to do 0.2, 0.3, and 0.267 because 2 goes with the value of 6, 0.3 goes with the value of 7, and 0.267 goes with the value of 8. If we add those all up, we get 0.767, which is 76.7%. Okay, now notice they said what percentage were in year 8 or below. So you're including 8. If they said less than 8, you wouldn't include 8. If they said more than 8, you would say that would refer to values 9, 10, and 11. All right, so for letter F, we took care of this guy. For letter F, what percentage of the children were above year 9? All right, so let's do blue for that guy. Above year 9, so greater than 9, would be 10 and 11. So for letter F, 0.067, 0.033. 0.067 is the value of 10, the relative frequency of the value of 10. And then we have the relative frequency for the value of 11. If we add those together, we get 0.100, which is 10%. Okay, I hope you enjoyed this lesson. I thought it was fun to do. Thanks for watching and good luck doing the extra practice. Have a great day, everybody.